Okay, so just to refresh, g of x is 5x to the 1/2 divided by f of x, which is 4x to the 2/3. Okay. Now we really can't do anything yet because our exponents are not the same. These are not like terms. Now I gave you a hint. What's our hint? We want to get a common denominator. What would the common denominator be here? 6. So what do I need to multiply this guy by? 2 over 2. And the top one by? 3 over 3. So let's rewrite those fractions now. The numerator is going to be 5x to the what? 3 over 6. And the denominator? 4x to the 4 over 6. Okay, let's simplify that. Now that my exponents have a common denominator, what do I do with them when I divide? Subtract. So what's left on top? Well, the 5, right? Okay, what's on the bottom? 4x to the what? 4, 6 minus 3, 6? 1, 6. Remember, we keep our denominators. Our denominators are the same. And the numerator we subtract. Why are my x's on the bottom and not on the top? Do I have more x's on the bottom or on the top? This is x to the 4, 6, and this one is x to the 3, 6. Which one is there more of? The 4, 6. So that's why we move them to the bottom. Okay? Now, there is something that we can't have. If I have a fraction in the denominator, that means I'm taking the root, correct? We can't have a root in the denominator. So I wrote myself a note there. Okay, which is right there. We can't have a root in the denominator. So I need to get rid of it. I need to multiply the numerator and the denominator by something that will get rid of that root. X, I'm going to multiply by x to the 5, 6. And let's think about why. X to the 1, 6 times x to the 5, 6. What does that give me? X to the 6, 6. And what's 6, 6? Just 1. So what would I have instead? I would have 5x to the 5, 6 in the numerator. And in the denominator, I would have 4x. And that would be our answer. Because why? Does that make sense? Okay. So I have a root in the denominator, which I can't have, right? We've been doing this since Unit 5, the beginning of Unit 5. So I need to get rid of that root. When I multiply the numerator and the denominator by x to the 5, 6, what does that give me in the denominator? X to the 1, 6 times x to the 5, 6 gives me x to the 6, 6. And 6, 6 is just 1. So that's where that 4x comes from. Now whatever we do to the bottom, we have to do to the top. So on top we have 5x to the 5, 6. And we have no more roots in the denominator, so we're okay. Yeah. Because just thinking about it, I know that when I multiply these two guys together that they're going to give me 1. So it's always just going to be 1 less than what the denominator is. What's the domain here? All reals or all positive reals? How'd you get positive? Because of that 6. So this is going to be all positive reals, or real numbers. It's because the denominator is even. So it's all positive, all non-negative, it's all the same. Okay, how do you feel about it? Okay, we're going to do one more. It's called a composition. So composition means we're actually going to be putting two functions inside of each other. Okay, so when we're taking a composition, we're going to start by first evaluating the most inside parentheses, and then we're going to work our way out, and I'll show you what I mean. Okay, so we're going to work with two new functions here. F of x is 3x plus 2. G of x is negative x squared. And h of x is x minus 2 over 5. But I don't think we're going to have enough time to do one of the examples with h of x. Okay. So what does this mean? The first thing we need to do is simplify the most inside one. So that means f of 3. So in f of x, everywhere I see x, I'm going to put in 3. So f of 3 gives me 3 times 3 plus 2, which is 9 plus 2, which is 11. So now I'm going to take f of 3 equals 11. So I'm going to substitute f of 3 in and put 11. So my new one is going to be g of 11. So now I'm looking at g of x, and everywhere that I see x, I'm going to put 11. So I have negative 11 squared. Now what's the squared attached to, the 11 or the negative 11? Just the 11, because negative 11 is not in parentheses. Negative 11 squared and negative 11 in parentheses squared are two different things. This one gives me what? Negative 121. This one gives me positive 121. So what's my answer going to be here? Negative 121. Make sense? Yeah? Sure. What would the domain here be? All reals. Because if we look at our two functions that we're working with, we can plug anything we want in there. So domain is all reals.